Okay, so welcome. In this little quick virtual lab, this is very similar to what you guys discovered in the previous lab. This is kind of set up just to do practice with real numbers to see if we can confirm what we already sort of discovered in previous labs and talked about in class. So, 4 objectives here. For our series circuit, do the voltages across each resistor add up to the voltage provided by the battery? So you can go back and look at our roller coaster model video to sort of figure out why that should be the case. Is the current the same in different parts of the circuit? And again, refer back to our roller coaster model for that. Also, we're going to apply Ohm's law and try to see what we get for values of this red resistor, this blue resistor, this green resistor. We did that in a previous lab, but we're going to do it again here all together by measuring the voltages and the currents. And finally, we're going to check out this relationship where if we add up the value of these resistors, do we get the observed total resistance that we get from Ohm's law? So we're going to check those out. So this is kind of a confirmation experiment, but I think it's good to do just to check to see if the math works out, the rules work out based on what we've already discovered. Okay, so let's go over to our first part. First thing we're going to look at is we're going to see if the voltages across each resistor add up. So I've got my circuit set up here. I've got my red, I've got my blue, I've got my green. I've got spots to write this down. I'm not going to write it on the board. I'm going to write it on my paper. You're going to be responsible for writing it on your own paper and then inputting it into the usual survey below to show that you've done your homework, okay? So I'm going to measure the voltages, the red, the blue, and the green. I've got my multimeter right here. So let me do that. Here we go. So my red voltage, I'm measuring that. And let's make sure everything's set up. Technical difficulties. There we go. Now we're in good shape. So my red, 1.68 volts. So I'll write that down. My red, my voltage across my red, 1.68 volts. Don't forget your units. That's my VR. Now my VB for the blue. Measuring that, I have 0.84 volts. 0.84 volts. Voltage across my blue, 0.84 volts. And now we'll do my green. Well, that's the last one there. Voltage across my green, I'm measuring, and I'm getting 0.42 volts. Okay, I'm writing it down, 0.42 volts. And eventually you're going to copy these into the online form. Now, I'm going to measure the voltage that my battery is providing, which is actually not a battery, it's a power supply, a little bit more reliable. So I go across here, and this is what my battery is providing, and I measure that, and I get 2.98 volts. Don't forget units, 2.98 volts. So again, what I've got for my voltage across my red, 1.68 volts. Across my blue, 0.84 volts. Across my green, 0.42 volts. And when I measured across the whole thing, what my battery was providing, I got 2.98 volts. Okay? So this is what I want you to do. We're going to test this rule here, whether or not the voltages across each resistor add up to the total voltage provided by our power supply. So you just add them up. Take these 3 numbers, 1, 2, 3, add them up. That's what we put right here. I'm not going to do it. I'm going to let you do it. Make sure you have that number separately. And then I want to know, are these the same or different? And if they are different, are they different by a lot, little? Let's check it out. Let's find out. Okay? So I'll give you a moment. Go ahead and pause. Do what you got to do with calculating, and then we'll come back. Okay. So hopefully you found things were good there. Let's go on to the next part. Next part is we're going to take apart our circuit. We're going to measure the current going through these different parts. 1, 2, 3, 4 different parts of our circuit. and we're going to see if the current is the same, which is what we're kind of expecting based on our model. So I'm going to turn this thing over to A for amps, and I move this thing to amps. And if you remember, we have to break apart the circuit in order to do this. So I'm going to go into point W. So for point W, to get that connection, I'm measuring the current, not very big, 0.0, we'll round that, no, I think we're good, 0.078 amps, okay, 0.078 amps, I'll write that down, IW, 0.078 amps, which is the same thing as a coulomb per second. Now, I'm going to reattach there, and I'm going to go into point X, so I break this apart, and for point X, I'm measuring, and I got 0.082 amps. Write that down, 0.082 amps. A little different. Okay. Now we're going to go for point Y. Why? Because. All right. And I'm measuring now. 0.082 amps. 0.082 amps. Okay, I'll write that down. 0.082 amps. And now we're going for a point Z. So I break it apart here. We'll go for point Z. 0.0, let me give it a moment, 0.082 amps. All right, those are all the same. So I got for Z, for these three, I'm seeing 0.082 amps. For this one, interesting, 0.078. You know what? I'm going to remeasure that. Curious. Very curious. So if I remeasure that, break that apart. Here we go. Wow, there we go. 0.084. Interesting. But if we look at these, here's a question. We see 0.084, 0.082, 0.082. They're kind of different, but are they significantly different? I'll let you decide. All right. So, take a moment, reflect, and you can answer your questions. Are the currents the same in all parts of a series circuit? Okay. Next part. And feel free to pause at any moment and rewind. All right. Now, here comes the math part. We've got our data. Here comes the math part. Okay? This is where you've got your piece of paper with everything written down, and you're going to start doing some calculations. So to calculate the resistance of our red, blue, and green, as well as our total, we're going to do Ohm's law. Okay? V equals IR. So if Ohm's law says V equals IR, and we solve for R, we do that by dividing both sides by I. So we have R equals V over I. So this is what you're going to do. Okay? You're going to take the voltages you had from before, okay? And you're going to substitute in voltage for the red and divide it by the current that we just measured. And I would go with the 0.082 amps for the current. That's probably a little bit more reliable. We saw that more times than we saw the 0.084. So 0.082 is probably the better number for the current as you're looking at the paper. So take your voltage, divide by the current, voltage divided by current, voltage divided by current for the red, the blue, the green, and the voltage that that battery was providing, the 2.98, take that and divide by the current as well. Because the idea is, imagine we had just one giant resistor replacing the green, the blue, and the red. That would be the total resistance of the circuit. So you're going to calculate using Ohm's law the total resistance by taking that voltage the battery provides that we measured and dividing it by that same current, 0.082. And that's what we get here. Okay, that's objective 3. And objective 4, all right, well, go ahead, pause, and get those values. Okay, so objective 4, now that you've got all these resistances, is to test our rule about the total resistance, whether or not they just add up. So what you're going to do is, you're going to take this value, these 3 resistors that you just calculated the value of, and add them up. And what we want to know is, when you add these 3 up, does it agree with what we measured from Ohm's law? Okay? So go ahead, do that calculation, compare, and then you're going to fill in the Google form with your answers. Nice job.